Good morning, everyone. In the last session, we discussed about the Java.lang classes information here. Now, along with this particular Java.lang classes, the Vapor classes, whatever we discuss here, we have some other classes we need to understand here how this particular classes are going to be created. Now, the main classes, if we observe, one of the important class, this is also process class. So process class basically what it will do, it will try to start the execution programming here. Now, if you observe carefully, whenever we are running the main method, the programs are going to be started here. How the programs are starting basically because of this particular like a process class. Now, if you see, this is one of the abstract class here. Now here you can see process class. Now, if I show you this particular class, now here you can see this is the one public constructor we are having, and this is something like output stream is one of the abstract method. Now here you can see input stream, error stream, wait for. So these are the some methods we are having abstract method, and some of the methods are non-abstract method. Non-abstract is nothing but concrete methods here. So now here you can see what you can identify. Wait for method here. Now exit value. Most of the methods are abstract methods we are having. Now here what you need to understand here, this the process class, it is going to be started the process. So that is something like executing a program. Okay. Now here this is primarily, it is going to be primarily, it is a super class for all the type of objects. It's going to be created as a execute here. So in the runtime class, basically this particular class by default, it is going to be extended to the all the type of object classes. Object class is nothing but integer is one of the object class. Character is one of the object class. Char basically it is a primitive type. So some way, now what are the objects we are going to create for all the classes? By default, this process is going to be extended as a super class here. Okay. Now if you see this particular process class internally it is extending from this particular object class here. Okay. So even though this process is extending most of the classes, but process itself internally it is extending from this particular object class. So this is what we need to understand here. Now what exactly this process class is going to do, it will try to execute the program whenever we are going to start here. Now another important section basically, now another example, if you see here, we are trying to discuss about the process builder also. Process builder. Now, what exactly this process builder it will do? Whenever the program is going to start by calling this particular start method in the process builder class, the process it is going to be started automatically here. Now, so to understand this, here we are having one more class, process builder. Now here you can see this is also is coming under the Java dot line package. Now, what we need to understand here, you need to understand this is the one of the important constructor which is expecting list of string commands. Okay. Now, another one is this is something like a var concept here. So, string of commands here. Now, this is the command method which is added under this particular process builder. What exactly it will do, it will try to add a list of commands here. So using the constructor we can add, otherwise we can call this particular method called command. After creating a default object you can call this also. Okay. Now here you can see this is the same one more command method. It will try to take care of var argo string related parameters here. Now whenever you're calling command method internally, it will try to return these are the list of commands here. Now, what exactly this particular section is going to do? The process builder class, what exactly it is doing it? Here, it is going to run this particular current program. Now, if we want to understand here we are having one method called, one second. Okay. Now, observe carefully here. What we need to understand here, destroy method. So destroy method. Now here you can see this destroy method. what exactly this desktime method will do. Now here, okay, not this, under the process class, if you go to here, so here you can see public abstract void desktime. Now what exactly this particular desktime method will do? It is going to be terminate this particular current program here. Now another method, if you see desktime forcibly. Now if you see here, whenever you are calling this particular method internally, again it is calling this particular desktime. But here, what is saying this information? It is going to kill the process forcefully. Okay, so the particular process is represented by the current object here. Currently, the whatever the current operation we are doing here, it is going to be terminated forcefully here. Now another important section, desktime method. Now this desktime basically it is going to kill the process, but once this particular termination, it's going to be happen normally. It is not going to take care of forcibly. Getting the point. So this is the differences between these two here. So desktime method and desktime forcibly here. Now what you understand this particular method, basically this particular methods are going to be checked whether the program is in the live status or it is in the desktime status. Now if you see is alive method. Now here you can see it is trying to return as a boolean method. Okay, it is trying to return as a boolean value. What you need to understand here, whenever you're calling is alive, if the process in the active status, it will return as a true, otherwise it will try to return as a false here. Okay, so here what we are doing here, we are calling the exit value method. So based on this particular exit value, it will try to return either false or either true. Okay, now observe what exactly this exit value is saying. So return the exit value of this particular process. So now the exit value of the process is represented by this particular process object. Now what you understand is this particular value, whatever the exit value we are trying to return, exit value is not something like a integer related value we are getting. Now what exactly it will return here? Based on this particular process object, based on the current process object, it is going to return by this particular exit value. Now internally we can check whether the given object is alive or it is terminated here. Okay, now one more method we are having, wait for method. So wait for method, what exactly it will do? It is going to return the exit code. Okay, so it is going to return the exit code, so that is going to return by this particular process here, that is going to return by this particular process here. And this method does not return until the process which is called terminated. Okay, so if you observe carefully, we are having wait for method. So this is the one of the wait for method. What exactly this wait for method is returning? Now again, this is also will return the boolean value, but this particular boolean value, it is going to return based on this particular exit value. Okay, if this particular method is returning exit value, it will return true. Okay, otherwise, now if you get any exception, this is the calculation is going to do. So and otherwise, now it will try to return as a false here. But here, now if you observe, we are under the do and while loop here. We are under the do and do while loop. Now what you need to understand here, if you see here we are having long values. If this long value greater than 0, until this particular long value condition false, it will keep on running this particular block of code. Now what exactly this particular wait for method will do? It will try to return the particular boolean status, it is waiting or not, but this particular boolean status, it is going to be written based on this particular exit value. Okay, so this is very important, we need to understand here. Now this method does not return until the current process which is going to terminated. Okay, so wait for is nothing but it will try to terminate the current process, then only it will try to return this particular section of code. So this is one of the important the class. So now we are going to discuss like all the programs we are going to start. By default this particular class is going to be executed here. Okay, this is also important class here. Now go for the another important class called runtime here. Now runtime, basically what exactly it will do? So here it will try to provide the runtime environment here. Now, basically, runtime environments is nothing but here, if you want to get the what exactly the runtime environments we are having. So if you see, let me show you the runtime environment class also here. These are the predefined classes which are going to be used under the like internal classes. So these are not external classes. Whenever you are running any program, these are the classes are going to be used here. Okay, now you can see runtime class we are having. Runtime class, what exactly it will do? It will try to provide the runtime environment. Now here we cannot create a object of this particular class. Here you can see the constructor we are having private. We cannot create a object of this particular runtime class. Now here we are having a method called get runtime. Now it is trying to return as a current runtime. Now here you can see current runtime here. Here, so internally it is trying to create with help of this particular private static final runtime. Only one runtime object it is going to be created. The same runtime object we are going to be reuse multiple location. Now here you can see every Java application has a single instance of class. Getting the point. Every Java application, it is going to have a single instance of class. What is a single instance? This runtime is going to have a single instance of class. And what exactly it will do? It is going to allow the application to, it is going to allow the application to interface with the environment in which the application is running. Now, what you understand is inside the which environment this application is running, it is going to provide the information by this particular runtime class. Now, what exactly we'll do? We'll call this get runtime method. It will try to return as a this runtime object here. Now, after, so once you call this particular runtime class, now we'll get the current object, and along with the current object, we are going to have a several methods here. So, what are the several methods we are having? Now, if we observe here, so here you can see exit method. So, what exactly this exit method will do? Now here you can see it terminates the currently running Java virtual machine. So what is saying here? It is going to terminate the whatever the currently running the Java virtual machine, something like JVM. So by calling this particular exit method. Now here what you need to provide here? You need to provide the status here. Now if you see the system.exit method is also similar method, it is going to do this particular same operations here. It is going to be stop this particular current execution here. Getting the point? Now, this method never return this particular never return any value, because once a JVM is shut down, we are not going to be return any value. Okay, so now what you understand here, because of this particular method we are making as a void here. Now what exactly we are checking here? First we are loading the security manager based on the security manager. But here, if you observe carefully, the security manager from which class we are loading? System. System is also one of the important class. This system class already defined under the package called java.lang package. Now what you understand here? Java.lang package is one of the important package, and because this java.lang package will contain core libraries for all the Java related example and whatever the application we are going to write here, everything which is going to taken care from this particular java.lang package here. So because of this, now we need to understand what are the internal classes we are having. Okay, what are the internal classes we are having? Now observe carefully. So inside this system is one of the core class here. Now using this, we are calling the get security manager. Once a security manager is not equals to null, we are calling check exist. Based on this particular status, now we can call, and here if you see, it is going to call the shutdown. It is going to call the shutdown here. Okay, now what you understand this particular exit method, what exactly it is to execute the program based on this particular status code here. Now terminating, it is going to be terminate the current program here. Okay, so same way, if you see, if we observe the remaining method, whatever the remaining method we are having, hide shutdown hook. So what exactly this particular shutdown hook method is doing it. So it is going to register a thread. Okay, so it is going to register. If you see here, what is the object we are passing? Thread object we are passing. Now it is going to register this particular thread object here to be a, so this particular thread, it is going to be run at runtime, but under the JVM. So this is very important here. Whenever you are calling this particular shutdown hook method, while calling, we are going to specify this particular thread class. Okay, the thread class as a parameter. What exactly it will do? It is going to register this particular thread at runtime under this particular Java virtual machine here. Okay, so now this is also very important here. If you want to register any customized thread, so what we can do, we can call this particular method. It is going to be registered here. Now internally, we are loading the same security manager. We need some security related credentials. Then only we'll try to add this particular current thread here. Okay, now after this, if you are checking this, now internally it is going to call this particular shutdown hook. Otherwise, this particular hook, if the permission is not having, it is not going to be added into this particular JVM here. Now remove the shutdown hook. So the above method is going to add, this method is going to be removed from this particular JVM here. And what about this particular halt method? Now, what exactly this particular halt method is doing? So immediately it is going to terminate the Java virtual machine. Okay, so here you can see forcibly terminate the current running Java virtual machine. So if I want to stop the current JVM, you can call this particular halt method. So based on this, it is going to be terminated here. Okay, so this is also important method here. Sometimes if it is required, if you want to terminate the JVM, you can call this particular runtime.halt method, provide the status. Now it is going to be terminated here. Okay, so mainly we are not going to be used, but in future if it is required, we can go for this particular runtime class here. But in the current application level, we are not going to use, because we are not going to be add any customized threads to the JVM, because by default the JVM is going to take care of adding all the customized threads here. Okay, so this is what we need to understand here. Now we'll go for the another important section called memory management related stuff. How this memory management is going to be written. To understand this particular memory management stuff here, what we can identify here. So same, whatever the runtime we are having, runtime dot get runtime class we need to create here, and it will try to return as a runtime object here. So once we get this particular runtime object here, okay, now observe carefully. Once we get this particular runtime object, now what I'm doing it, now here I'm trying to find out the current memory as well as total memory, available memory and total memory. So how we are going to identify here? Now here you can see memory 1 and memory 2. Now what I'm doing here, integer array object I'm trying to create here. Okay, so this is something like a new integer. So I'm trying to create a space as a 1000, so that we can insert 1000 values. Now after this, what I'm doing here, I'm going to print this runtime dot. Now what we can do, total memory. Here you can see total memory. Okay, so whenever I'm running, what it will do, it will try to return the total memory, and from this particular runtime. Okay, so what I'm doing is free memory I'm trying to load. Okay, now if you see long L, so free memory, it is trying to return as a long related value. Now what we can do, we'll try to store as a memory 1 here. Okay, memory 1. Now another important one, so this is something like initial free memory. Okay, as of now we did not initialize any value. Getting the point. So total memory we are loading, and what is the free memory also we are trying to find out here. Now we'll print this. We'll try to print this particular. Okay. So after this, now what I'm doing here we are having runtime dot gc. So what exactly this gc will do? Okay. Now if you observe carefully, whenever you're calling this particular gc, now if you understand here, so it is going to initiate the garbage collection. So gc is something like it is going to start the collecting the unused object here. Okay, it is going to collect this particular unused object here. Now after this, now one more time I'm calling the same free memory. After this particular garbage collection, here what we can define here, so free memory after, so gc call after gc. Okay, now we'll identify what is this free memory it is going to be returning here. Now what I'm doing here, after this, here I'm trying to do this particular for loop into I is equals to 0, I less than, here simply we can give the 1000 and I plus plus. Here now what I'm doing here, okay, so this is the array of values, I is equals to new integer and whatever the I value we are having. I'm trying to create a object here, or this integer is already deprecated. Now what we can do, go for this particular integer dot value of, okay, it will try to return this particular current object here. Okay, now so thousands objects now I'm trying to allocating here. Thousands object now I'm trying to allocating. Now what I'm doing here, so again I'm going to copy this, but at this time I'm trying to paste initializing into memory 2. Okay, so this is what we need to understand here after allocation of this integer object. Free memory after allocation. Okay, so this is what we need to understand here. Now currently what we will do, so how much memory we used here? How much memory we used here? Now how we can identify this? So to understand this particular memory concept here, what we will do basically, we'll try to print this particular memory 1, memory 2. So whenever I'm doing the subtraction, we'll get the current free memory. Current free memory. So now, as of now, we'll observe here. Let me run this example as of now. How many the current memory we are having, how the garbage collector is performing to collect this particular object. So if you see what I'm trying to print here, from where I copied this one. So yeah, if you see the line number 12, this is the total memory. This is the total memory we can store into this particular JVM. Okay, now if you see, so now after calling this particular total memory, what is the current free memory we are having? So this is the initial free memory. Now if you see this 2684 35456 something, but here 266. So some changes are there from this particular total to the free memory. Now after this particular GC, whenever this particular GC is going to be collect the unused objects here, now this is the memory we are having currently. Okay, this is the memory we are having. Now after this, what we did basically here, we store some value here. into this particular integer array, we store some value. So whenever we store, again I'm loading the current memory allocation. Now if you see, after collecting the GC, the garbage collection, now this is the free memory we are having, but after initializing the some value into this particular array, the integer array, now this is the current memory we are having. Now if you see, if I'm doing this particular subtraction, so this is the current memory we are having. Okay, so this is the current memory we used for our integer array. This is the current memory we used for this particular, whatever this integer array we used here. Line number 18, what we did basically, we initialize all the values. We initialize all the 1000 records. For this particular 1000 records here, now this is the memory it is used here. It is used. So now what I'm doing here, as of now, so we collected the free memory and we initialize some value. After that we identified, so what is the memory we use it for this particular current example to store the 1000 records under this particular integer array. Now after this, now what I'm doing here I'm trying to making as a all the values as a null. So I'm copying the same thing here. Okay, now this is a same for loop I'm going to use, but here instead of storing the values, now what I'm doing here, I'm making all the objects are null. All the objects are null. So whenever we are making object as a null, now what we can do, we'll call the runtime.gc method. Now what it will do, whatever the unused object we are going to have, all the unused objects are going to be picked up here. Okay, all the unused objects are going to be picked up here. So now again I'm going to, after garbage collection, now I'm trying to print this particular memory here. So now if you see, so what is the last memory we are going to get here after collecting unused objects. Okay, so this is what we need to understand here. Now if you see, finally what is the result we are going to get here. Now if I'm going to start this as a debug mode, now what we will understand basically, if you see runtime class we are loading and we are trying to create a integer. Now if you see, so structure is created, but if you see all the elements are null here. We did not initialize any value. Okay, now you can see runtime dot free memory, and this is the memory one we are getting. Now this is some bigger memory we are getting. Okay, now if you go to this console, this is something like total memory we are having, but currently, so this is the free memory we are having. Okay, because if you observe carefully from the total memory, already some objects are already occupied some memory. So currently this is the free memory we are having. Now what I'm doing here, so again I'm calling the GC. So why I'm calling this GC? If any objects are, if any unused object if we found, so those are going to be removed from this particular free memory location. So that will get a little bit more here. Now if you see, after printing this, now what we are getting is, after this particular GC, now this is the memory we identified here. After collecting this particular GC, this is the new memory we identified. Now what I am doing is, so this is the for loop. It is going to insert all the 1000 records. Now if you see, if you go to the, we are having 99, but here if you see 900 more items here. So 1000 records we inserted. Okay, into this particular array. Earlier it was 0, but currently we inserted 1000 records. Now after this, after inserting this particular value, what I am doing is, I am trying to check what is the current memory now. Okay, so this is the current memory. So if you see, this is the, after collecting the GC, this is the memory we identified. From this particular memory, now we initialize the 1000 records. So currently we are having this much free memory. Now you can see, if I do this subtraction from memory 1 to memory 2, this is the memory it is allocated for store the 1000 records into this particular array. What is an array we are having? This is an integer array. Okay. Now this is the 1000 records are stored this much memory here. After this, now what I'm doing here, I'm making all the values null. So if you see as of now, all the records we are able to see. All the records we are able to see. Now whenever I run the line number 24, you cannot see the objects here. So you can see all elements are null. All elements are null. Now what happens internally? The 1000 records now we are making as a null. So again I'm calling this GC. So what it will do this particular GC? Unused objects. Unused objects are going to be picked up here. Okay. Now finally I'm trying to call this particular memory here. So this is the memory we got currently. This is the free memory we are having. So now what you understand here, using this particular runtime class, now we are able to find out the total memory related stuff also. So you can see how much this runtime class is important here. So try to debug this particular runtime class. You will understand more information regarding the JVM related here. Okay. So it is going to have lot of methods. So exit method we discuss here, alt method we discuss here, something like a load method. Okay. GC method, something like garbage, runtime we are having. Okay. So we are having number of methods here. We are having number of methods. For example, after this particular memory, if I want to call here, we are having exit here. So I'm going to give something like a status as a 10 here. Now, if you observe what exactly this exit method will do. Okay. Now after this, I'm calling. So here you can see method will fail. So why method will fail? Because we are explicitly stopping this particular program here. Now you can see it is stopped here. Okay. Whenever you are calling this exit, it will stop this particular application here. So this particular same exit method we are going to use in the Spring related application also. But by default, it is going to be come from this particular class here. Whatever the runtime class we are using, from this particular runtime class only, it is going to be used here. Okay. So this is what we need to understand regarding this particular memory management related stuff under this particular runtime class here. So any questions? Okay. So basically it is going to be store as a this particular values as a MVs here. If we observe in the real time application how the space we are going to provide here, we'll try to give as a something like a XMX value. Okay. So this particular section of values now we'll try to store as the memory information under the JVM. So by default, this is the total memory we are having under this particular JVM here. Okay. Now, if you observe any real-time application explicitly will increase the memory to handle the current application here. Currently, this particular memory we are having, if the memory it is not going to be supported sometimes in the real-time application, we'll go for the increment of this current memory so that we can perform the various object creations here. Okay. So this is what we need to understand. From the MBs, internally it will convert to GBs here. Okay. So if it is clear regarding this particular memory related stuff here, we'll go for the another important section called So system class. Now if you want to understand the system is also one of the important class because we already identified few of the information, but we'll try to see what are the other information we are having. So mainly why I'm explaining this information here, because these are the java.lang package. It will give you the more understanding about the Java language here. Now if you see, this is the one system class. Okay, system basically what it will do. Earlier, whatever we discussed here, it is trying to provide the system.out.println, like the print related purpose we already identified here. Now you can see, again, this is also one of the final class. Most of the classes, if you go any java.lang related sections, most of the classes are final. So that those classes are not going to be extended to any other classes here. Okay, now what you can identify here, you can see again it is having private constructor. Whenever we are having private constructor, we cannot create an object of this particular system class here. But how we are going to access it? Using, if you see, if I want to access this input stream, static final, directly class name dot this particular in variable. Now this is the out variable and error relate. Okay, we already discussed the input stream, output stream, the print stream related concepts here. But now what you need to understand here, so this particular, okay, this particular class also, the system class also, it is going to have lot of methods here. It is going to have lot of methods. Now what are the lot of methods we are having under this particular system class here? Now this particular system class, it is going to hold most of the methods as a static method, so that directly without creating an object we can access this particular system class methods here. Now if we observe carefully, input stream, output stream we already discussed in the previous classes here, so no need to discuss about this. Now here you can see setting. Now what is the parameter we are passing? Input stream. Okay, now it will try to take care of printing the value based on the location where we want to print, either console or file related stuff here. Now if you see this particular system class, now it is having console. Console is a one class here. Now if you see java.io.console, console is one of the class we are having. Okay, now where we are using this particular console here. Now if you see public static console and console method. So console method, now it is trying to return as a this particular console. If you want to print any values, getting the pen, it will try to, it will, if you want to print any values on the console, you can call this particular method, it will try to print this. But here if you see, so console basically what is doing it is trying to return the console object first. Okay, this method purpose basically it will try to return as a console object. Now what exactly will do this particular console object here? Now here you can see again this is also one of the final class. Now if you understand here writer method, what is doing here? It is trying to return as a print writer. We already discussed this particular print writer section here. If I want to print something console or file related, we can go for this particular print related. Here we are having reader class. Okay, so format, what is the format we want to print this? So basically this particular section of code, now to print the information console or file related stuff, we can go for this particular section of code. So print line method, printf method, like a read line, if we want to read something from the command line or from the file related stuff, we can use, these are the methods here. Okay, same thing. Now from the system class we can access the console method, so that we'll get as a console object here. So once we get the console object, we'll do the various operations here. Now coming back to here, what are the other methods we are having here? So other method, current time millis. Now if we want to understand the current time, millis. Now here you can see this method will give you the what is the current time here. Okay, and here also we are having GC method. Here also we are having GC method. Along with the GC method, here you can see same exit method we are having to stop the current application here. Now here you can see we are having array copy method. We already We already discussed about this particular array copy. What exactly this array copy is doing here? So it is going to be provide the object to source, so destination. Now, what is the source position and the destination position, and what is the length? Now, what exactly this method will do? It is going to copy the from the source array to destination array. This is the copy something like a cloning here. Okay, this is important here. So same way we'll have a number of methods here. So based on this, now we can identify the what exactly this particular system class is going to provide you. To understand this, now what we will do, we'll try to identify the simple example here. If you go to here, system dot, here, if I want to identify the current time millis, now what exactly it will try to print here? What exactly? Okay, so we need to stop this because the program is going to be stopped here. Here, long I'm trying to take start comma end time. Okay, start time and end time here. Start is equals to system dot current millis. So current time we are going to get. Now after this, what I'm doing here. So this is the for loop I'm doing here. L is equals to 0. Okay. Now here long I less than. So this is the condition I'm given. Just this loop is going to be repeated. Just this particular loop is going to repeat it. I'm not doing any operation. So after this, system dot same current time I want to load. Okay, same current time I want to load. Now, if I print this particular what is the time is taken for this particular for loop operation. Okay, for loop operation. So what we can do instead of writing this, so directly end minus start. Now what exactly it will do? So what is the time it is going to take in to perform this particular for loop operation here? Okay, so now observe carefully how this particular current to the time millis method is doing here. Now if you can see, so this is taken 13 milliseconds. Okay, so 13 milliseconds to perform this particular operations here. So what is operation? This particular for loop operations here. Okay, so if I print this as a debug, now we will get as a different outputs here. We'll get as a different outputs here. Now, if you go to here, 17. Why we are getting 17? Because so explicitly we only stop this particular application here. Because of this, in the debug mode, we could not get the current to the expected result here. But it should run as application, not debug as application here. So using this particular current time here, now we are able to identify so how much time it is taken. So to print this, now current time and as well as end time I'm trying to print here. Now, if I'm trying to run the same example, here you can see this much is the starting time and this much is the ending time. Now it is trying to give as a milliseconds, and if we do the subtraction, so the 10 milliseconds is taken to perform this particular for loop operation. So what we can identify, if we want to check the current application or current program, how much time is taking, so we can do this particular method here. Same way, we can perform the whatever the other method I explained here using this particular method here. Okay, so this is also important method. Now what is another important method? Array copy. Array copy we already discussed in the previous example here. What exactly it will do? Once you provide the source node and destination node with a different position, it will try to copy here. Okay, these are the important method important classes as well as important method we are having under this particular java.lang package here. Now, so any questions still? Still anyone having any questions regarding this particular java.lang related some of the classes we discuss here, but we are having lot of classes here, so you need to identify, go to the java.lang package and try to identify the each and every class, so how it is going to be used internally. Okay, now if you don't have anything, now what we will do, we'll try to go for the one of the important concept to call collection framework. So collection framework basically it will try to store the multiple values with the different data types here. So as of now, whatever we discuss here, those are going to store as a single object here. Okay, so using this particular array concept here, we can store the multiple object here. But whenever we are discussing this particular collection framework here, it is going to have more understanding about this particular Java language here with different data types we are going to store the values. We'll see what are the different classes and different interfaces we are having. Based on this particular different interfaces classes, how we are going to perform the various operations here. Okay, so this is very important section we need to understand here. Now this particular collection frameworks is implemented under the package called java.util. So far what we discuss here, those are java.lang package. Those are java.lang package here. Now observe carefully. Now observe carefully here under this particular java.util package, mainly it is contain the classes and interfaces. Mainly it's contain the classes and interfaces. Using this particular classes and interfaces, we'll try to perform the various operations here. So to understand this entire collection framework, first what we need to understand here, what are the interfaces we are having and how the interface having the method and how each and every interface methods are implemented internally. Okay, so first the first interface is collection. Okay, let me create a one package here so that we'll discuss all the collection related stuff under this particular collection framework here. Com.collection framework here. Now, so file I'm trying to create here, collection.txt. Now, why I'm trying to create this particular txt file here? So first, what I'm trying to discuss here, collection. Collection is one of the main interface. Collection is one of the main interface. So what exactly this particular collection is going to do here? So to understand this, now I'm trying to create a one Java class here. Collection test. Under this particular collection test, now I'm creating one main method to identify the collection interface. Now if you see, this is a collection interface. Okay, and all the collection framework, currently whatever the collection framework you are using, all are restructured with the help of this particular generic concept. We already discussed about the generic concept in the previous example here. Basically, what exactly this generic concept is going to provide, dynamically we can change the object to type. Dynamically we can change this particular object type. Because of this, now this entire collection framework is recreated here. So the first important interface is collection. Now if I show you this particular collection, you can see public interface collection, and this is, we'll call it as a generic concept here. Now internally it is extending from this particular iterable. Okay, so what is exactly this particular iterable will do here? Now if you see this, this is also one of the interface here. This is also one of the interface here. Now interface, whenever we are trying to discuss here, it's contain only abstract method, default method, static method. So these are the three different methods we are going to have here. So this is the abstract method. Under this particular iterable, what is the method we are having? Iterator. So carefully observe, iterable is different, iterator is different. Okay, now if you see, if I'm going to show you, so one more interface we are having. One more interface we are having, iterator. So inside the iterator, what are the methods we are having? First one is has next, second one is next. So iterator is this method has next and next method. Now if you see, so default method. Okay, this default method already we discussed. Now what is the default method we are having? Remove method. So currently this remove method is trying to throw an exception, but we'll see where this particular remove method is implemented. Now what is another method? So this is also one more default method which is coming from the 1.8 onwards here. Now this particular method, okay, maybe this is coming from the beginning, like 1.0 onwards here. So they did not provide the from which version onwards it is coming. Okay, but this method they have provided information when this method is introduced here. So if you see here for each remaining, now what exactly it is doing here? If you see objects dot required not null, whatever we are going to provide here, this object should available. If you provide the null, you will get an exception. You will get an exception. Here, what we are doing here, we are trying to repeat the one by one element using this particular has next here, and after this we are calling this particular action dot accept method. So to understand this accept method, what you need to understand? Consumer. Okay, we'll discuss later regarding this particular consumer, how it is going to be implemented. You can see this is one of the functional interface. This is one of the functional interface where we discuss about this particular functional interface in the lambda expression and the method references concept. We discuss about this particular functional interface. Now functional interface can contain only one and only one abstract method, that is called accept method. Okay, now here you can see default method. So this is the different concept, but this accept is a abstract method. If you try to create a one more abstract method, this particular class will not call it as a functional interface here. Okay, now coming back to here, so whenever I'm discussing about this particular collection interface, so how many how many references we are having here? How many references we are having? Now if you see, we'll discuss these are the three dependent interfaces here, but what you need to understand this particular interface here. So if you read this, this is the main important concept about this particular collection interface. Okay, this is the root interface of the collection hierarchy. If you see here, so the package itself is giving the information. This is the root interface here. This particular collection, it is going to represent the group of objects. Group of objects. We'll understand in the array also, we'll try to store group of objects here. But what exactly this differences between arrays and the collection framework here. Now if you observe this group of object, we'll call it as a elements here. Because of this particular elements only, this here the interface level we are trying to provide as a the generic type E. So E, what exactly it is providing here? Element here. Okay. So whenever we are trying to store any record, we'll try to call it as a element here. Now if you come back below, like here you can see some collections is going to allow duplicate elements, some others do not allow duplication here. So some of them are ordered, some of them are unordered. Now what you understand here, the collection framework information here only it is giving here. So this is the collection framework root interface, and so this entire collection framework it is going to store as a group of objects here. So the group of object will call it as a elements here, and internally this group of objects it's going to be allow duplicates records, some of them are not allow the duplicates records, some collection frameworks are going to allow order, some of them are not order here. Okay, so this JDK does not provide any direct implementation of this particular interface here. Getting the point? So JDK by default it is not provided, but explicitly we created the all the implementation of this particular interfaces here. Okay, it's provide the implementation of more specific sub interfaces. So what are the sub interface we are having? Set interface, list interface. Okay, along with these two, we are having some additional interfaces also. We'll see what exactly these interfaces are going to be provided. Now, if you come little bit below, what is saying here? This particular certain methods are specified to be optional, and some methods are going to be thrown exceptions here. Okay, so some methods are going to be different. It's going to throw a different kind of exception. We'll see what are the different kind of exception. Here only it is providing unsupported operation exception, null pointer exception, class cast exception. Okay, now if you see some other exceptions also it is going to be through, like interrupter related exceptions also it's going to be through, that we'll discuss later. Now here you can see equals method, contains method, hash code method, object method. Okay, so like we have a different type of different type of methods we are going to discuss here. Now, so now you can see collection related and unmodifiable collection. So these are the unmodifiable collection related stuff here. Now we'll see, so modify related stuffs here. We'll observe one by one how it is going to have. Now if you see, so set is an interface, list is an interface, map we'll discuss later, set, sorted map, hash set, tree set, array list, linked list. These are the interfaces we are having. Along with the interfaces, we are having implementation classes also. Now, what we need to understand here, first, what are the methods this collection interface is having, and what is the purpose of each method? Okay, that we need to understand first here. Now, if you see, the first method is having size. So what exactly this particular size is going to do here? Collection interface, size method. Now, if you see here, here only it will give you the information. So return the number of elements in this particular collection, because collection is going to store group of elements. Whenever it is trying to store group of elements, now we need to identify currently how many elements are stored under this particular collection, like under this particular collection interface. Now how we are going to check? Using this particular size. So size will give you the current count, how many elements are stored. Now what is another important method? Boolean is empty. Now what exactly is empty method is returning? It's going to return true if this collection contains no elements. If this particular collection does not contain any value, it will try to return as a true. Otherwise, it will try to return as a false here. Okay, this is what we need to understand. The second method called is empty. So now you can see int is a return type, boolean is also return type. Size will come as a integer number. So is empty method, it is trying to return as a either true or false here. Now go back the another method. Now if you see contains method. So contains method basically what exactly it will do here, it is going to return the true if this collection contain the specified element. So what is the specified element here? Whatever the parameter we are going to pass, so that the parameterized element, basically this particular O, now it is going to play as important role called element here. Okay, so if this particular given element, if it is available under this particular collection, then it will try to return as a true. Otherwise, it will not return as a true. So simple understanding here. So simple understanding. For example, this is the collection I'm having. Okay, now I inserted around 5 or 6 records. 5 records I inserted. Okay, inside the 5 records, these are the values A, B, C, and D, as well as E. So these are the records I inserted A, B, C, D, A. Now what I am doing here, I am trying to call this contains method. Here I am passing the parameter. For example, if I pass F, so it will try to keep on checking the one by one object. It will keep on checking the one by one object here. If this particular F is going to match it with any record, if it is going to match it with any record, it will try to return as a true. Otherwise, it will not return as a true here. Otherwise, it will not return as a true here. So this is the main purpose of this particular contains method. So it's a simple method. Contains method, it will try to check whether given element is already existed under this particular collection framework or not. If it not, it will return as a false here. This is what we need to understand regarding this particular contains method. If you see returns, if you see here, it returns the true if this collection and contain the specified element. Okay. Now again, this particular contains at least one element should match here. At least one element should match. But this contains method, it may throw this type of exception. First exception, class cast exception, because the parameter we are passing as an object. The parameter we are passing as an object. Whenever we are trying to typecast to the specific data type, you will get a cast class exception. And the second one, null pointer. So we cannot compare with null objects here. So these are the two important exceptions we may get from this particular contains method here. Okay. So now we observe three methods here. We observe the three methods. Now go back to your iterator. So iterator basically what exactly this iterator will do, if you read this particular method purpose. So return an iterator over the element of this particular collection. Now basically this iterator is method. It will try to return as a iterator interface object here. Here we observe iterator, one of the interface here. Okay, what exactly, once we get this particular iterator object, now what we can do here, we can access these three methods. So as next and next method and default remove method. So one more we are having for each remaining. Okay, for each remaining we can access, these are the methods here. This is one of the important. We'll discuss later this iterator what it will do. Now if you observe carefully, an iterator over a collection, iterator takes the place of enumeration. So enumeration. So we did not discuss about this particular enumerations as of now. If you see, enumeration is also one more interface. Enumeration is also one more interface. Now if you see, one interface is dependent with another interface here. So that we cannot understand as of now what exactly it is doing here. But if you see this iterator, it will try to repeat one by one element here. Okay. So has next method, this has next method, what it will do? If the collection contain next element, if the collection contain the next element, it will print. Okay, otherwise it will return false here. So this is a Boolean method. Okay, so if we observe this method, it will return true if this iteration having more element. We'll debug the code and we'll explain how this particular has next and next methods are going to be implemented internally. Okay, but what you need to understand basically here, you need to understand here you need to understand the collection interface. Iterator method basically it will try to return the iterator, the interface object. So once the object we got it, we can call the has next and next method. So we'll see later what exactly the has next and next method will do. Now if you see toArray, what is the purpose of this particular toArray method? Whatever the collection type object we are having, now if we want to convert into the object array, if you want to convert it into the object array, you can go for this particular toArray method. It will try to return the return type as a object array here. So now you can see returns an array containing all the collection elements here. It's a simple one. Just if you want to convert object array, we can go for this particular toArray here. Now, what is the another method we are having? So if you see on top of each method, what type of exceptions also we may get, it will try to provide the information. Currently, this method will not get any exception. This method also, but this method, it may throw this type of two exceptions. This type of two exceptions here. Now come back below. Now this is a type here. So this is also a toArray method, but here what you need to understand, what is the differences between this toArray method and this toArray. The first difference here, this toArray is expecting this to array is expecting object as a the type parameter. Okay, is expecting one parameter that should be the type array, and this to array method is not expecting, and internally it is trying to return object array. But here this is not going to return as an object array. It is trying to return as a type. Type is very important here. This is something like a generic concept. If you provide the string, it will return string. If you provide the integer, it will return integer. But whereas here we don't have a scope here. Whereas this particular method does not have a this type of scope here. So simply if you call this to array, directly it will try to return as a object array. Directly it will try to return as a this particular object array. So this is what we need to understand here. This is what we need to understand, this particular object array and to array. So one more we are having, this is the default method. Now into function. Into function. So we need to understand this particular into function later, we'll see, but how it is going to be implemented here. Okay, I'm copying this method also. We'll try to debug one by one how it is going to be implemented here. Now copy this. So this method also we need to understand the differences between this to array and this to array. Okay, now come back here, default method. We'll try to call this to array internally. So generator dot apply. Generator, what is a generator? Reference type. Now what is the having the generator type here? Into function. Now if you see, into function is also internally functional interface. Now what is expecting here? R. What is the R? Return type. Here you can see it is trying to return R, but is expecting the into value. But it is expecting the into value. Now whenever you provide this particular into value, it will try to return as a based on the whatever the return type you are providing. Whatever the return type you are trying to providing here. Okay, so now observe carefully. Now here we need to go to array generator dot apply. It is something like we are calling abstract method. We are calling the particular abstract method. We'll see how this particular default method is implemented. Okay, now this is important. Boolean add e. So what exactly this particular boolean add e is providing the information? What exactly this particular boolean is providing the information? Now if you read this, what is saying here? Ensure that. Now here you can see ensure that this particular collection contain the specified element. Okay, if the element is contained, it is trying to return true. If the collection is changed, the result. If it is not changed, now it is not going to be written as a true. But what is the main purpose here? So this particular add method, it will try to add an element into the collection. Okay, so what is exactly this E is specifying? What is E here? It is E, basically it is a generic type. Where we provide this particular generic type here? If you go to your class level, sorry, interface level, here you can see, here we are providing the generic type, collection E. Now observe carefully how much this particular generic concept is very much important here, because in the previous example we already discussed multiple example. Now if you go to this particular generic, here we already discussed here. This is an auto bean average class. Here you can see T internally it is extending from this particular number. So T array. So bounded type we discuss here. Okay, and so generic class. So this is the non-generic class. Now this is the generic class. Now you can see here we are providing the T, but if you go to this particular collection, here what we are providing E. So the character is different, but purpose is same here. Why we are providing E? Here we are specifying we are going to store elements. Because of this we are going to provide E. But whereas if you see here, I provide as a T. T means type I'm trying to providing, object to type. Okay, because of this that is the main purpose here. So now observe carefully here, come back here, the add method, what exactly it is doing here. Whatever the type we are going to provide at interface level, the same type we are going to pass as a parameter. Same time. If you are trying to pass a different parameter, you will get a compilation error. So you cannot pass a different type here, because it is a generic concept here. So what is the main purpose this? It is going to add an object into this particular collection. If the object successfully added, it will try to return true. Otherwise, it will return as a false. So this is the add method. Now go for the another method, remove method. So carefully observe. Remove method, here we are not providing any E. Here we are providing the object. Whenever we are providing an object, this is an exception it may throw. This is an exception it may throw. If you see here, this add method, it is not going to throw class cast exception. This add method, it may throw these many exception, but there is no class cast exception here because okay, this it still it is throwing any cast class because whenever your converting, but rare case will get any this particular class cast here, but here, so this object as a parameter will get this object as a parameter we are passing. We may get a class cast exception little bit more times compared to the add method. So these all about the important section regarding this particular remove method. Okay, regarding this particular remove method. Now what you understand remove method, it will based on the parameter whatever we provided, it will try to remove the object from this particular collection. Whenever it is removed, the size of the collection also it's going to be decreased here. Okay, now contains all. Here if you see collection. What is a collection? Collection is an interface. Inside the interface, we are providing the same type as a parameter. What is this particular question mark? This question mark, we'll call it as a wildcard argument. Okay, whenever we are discussing this particular generic concept, we discuss about this. So what is the main purpose here? If you provide this particular bounded type here, so only one time it is going to allow. But here, the method parameter, we need to specify multiple types. Because of this, now we are going to come up with a wildcard argument here. Okay. So now if you go to the generic, whatever the previous classes we provided, you will understand the collection framework, entire collection framework is easily here. Now, what is the purpose of this particular contains all? Based on the collection of object, now the given collection of object are available under the collection or not. So if you see, return true if the collection contains all of the elements that are specified in the collection. Okay, for example, this particular method, here I'm passing 10 objects. These 10 objects, those are available under the current object, it will try to return as a true. Otherwise, it will not return as a true. Okay, this is what we need to understand here. Now, this is all about the contains all method. Just if you see, contains is checking one object, but contains all checking multiple objects at a time. But internally, this contains all method, it's going to call the same contains method. That we will see how the code is implemented internally. Okay, now coming back to here, add all method. So what exactly add all method is doing here? Now here you can see question mark, and here what we are doing here, we come up with a bounded type. So why we are providing the bounded type? It should be extended to this particular E. Okay, so if it is not providing this, we may get different type of exceptions. Here. So this is what we need to understand here. Okay, now what you need to understand add all. So add all, here it is expecting the collection of objects here. The collection of object basically, okay, the collection of object basically, what it will do? It will try to add one by one into the collection, the current collection based on this particular values. Now here, if you provide the 20 records, these 20 records are going to be inserted into the current collection framework here. So this is the main purpose. Add method, it is going to allow only one object, but add all method is going to take as a multiple values at a time, multiple values as a parameter. This is only the differences between add method and add all method. So now contains method is expecting multiple object as a parameter, but contains method is expecting single object as a parameter. This is the differences between these two here. Okay, now after this, what you can identify, remove all here. Remove all. Now, what you need to understand this particular remove all here. What exactly? The removal you understand. Now, if you go to this, so remove is expecting single object. Now, this removal is expecting collection. So, this is only the differences. How many the collection of object we are going to post? All objects are going to be removed one by one here. One by one. Okay. Now, again, this is the default method remove if. So predicate, we discussed about this particular predicate in the previous example. Whenever we are discussing about the, whenever we are trying to discuss about this particular lambda expressions as well as method references concept here. We'll see one more time how this particular remove method, remove if method is going to be implemented here. Okay, so this is a default remove method here. I am also copying this one so that we'll understand how this particular remove if method is implemented. So come back here, retain all. Retain all basically what are the conditions are satisfied, those records are going to be keep here, and what are the condition unconditional records. Unconditional records is nothing but matched records are going to be kept here, unmatched records are going to be removed. So this is the main purpose of this particular retain all here. So if you see, retain only the elements in this collection so that are contained a specified collection, something like matched records. The matched records are going to be keep as it is. Whatever the unmatched records we are going to have, so those unmatched records we are going to be removed from here. Okay, this is all about the important section regarding this particular retain all method. Okay, so now observe, we'll try to implement debug this particular retain all internally. We'll understand how this particular retain all is going to be used here. Now we'll discuss about the clear method. Clear basically it will try to remove all the elements from this particular collection. Okay, it will try to remove all the elements from this particular collection. Now equals method, we already discussed equals method. Just simply it will compare the two objects. Hash code method. Hash code is based on the current object, it will generate the hash code value. Okay, we'll see this equivalent hash code how it is generating. Now these are the default method. So these are the default method. We'll try to discuss one by one how this each and every default method we are having. How many we are having? First one is split iterator. How many we are having? Split iterator we are having. Second one is stream we are having. Okay, second one is stream we are having. Third one is parallel stream. We'll try to identify these are the default method, how it is going to be implemented internally. Okay, so these are the collection related interfaces here. Now, I'm stopping the session up here. We are going to continue tomorrow the extended interfaces. So currently, this is the root level interface. Whatever we are discussing the collection, this is the root level. From the root level, we'll have below sub interfaces. So what are the sub interfaces we are going to have? So that we'll try to identify in the tomorrow session. First, we'll discuss more about the interfaces concept so that we'll understand the how this particular collection framework hierarchy is implemented. So once a hierarchy we understand, we can easily understand about the particular implementation classes here. Okay, so any questions or regarding this particular collection interface and some other classes whatever we discussed in the previous session? Still anyone having any question? Okay, now if you don't have anything, so I'm going to stop this particular session. We'll continue tomorrow.